last time we talked, we were discussing how to do volume, and sometimes we had to work backwards from volumes, like in the pyramid problem, and sometimes we had to keep it set up, like in this problem over here. And sometimes we had to carve some things out of the volume. Now what we get to do is talk about what happens if there's another dimension involved, if there is a density involved. So let's take a look at this guy. We've got a shipping container that is 12 feet by 8.5 feet with a height of 4 feet. So we got a nice shipping container. Let's draw the shipping container. It's beautiful. 12, 8.5, and 4 feet. Container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. That right there is our conversion. So we have to start by doing the volume. Then we start in on the conversion. So with our volume, we do V equals 4 times 8.5 times 12. So we get our volume. And when we type that into our calculator, we should get 408, which is an option, and it is not the correct option because we haven't done our conversion yet. That's going to be 408 feet cubed. What you have to do then is take the 408 feet cubed, and you need to do a conversion on that. We're going to use this bright orange conversion right here that says 0.25 pounds is equal to 1 foot cubed. So 1 foot cubed is 0.25 pounds. Type that into the calculator and you get 102. Be very careful when you go through these. Same thing happens with the next one. With the next one, we've got a lawn ornament forming by a solid sphere. So we got this nice solid sphere. Clay being used to make the sphere weighs a certain conversion factor. We've got 0.075 pounds is equal to 1 inch cubed. And we've got a radius of 4 inches. So when we do the sphere, sphere is 4/3 pi r cubed. So 4/3 pi 4, make sure that's a cubed. All right, type that in, and we should get 268.083, which if you notice is not an option. They were nice to you. They made sure that you knew that that is not what we want to do. We want to take that 200 number and we need to convert it. Now this would be in inches cubed. And we're going to use that orange conversion right there. So 0.075 pounds over 1 inch cubed. Type that in and we should get 20.1. So we get 2 for that answer. Next one, a hemispherical water tank. A hemispherical water tank. Hemisphere means half a sphere. Inside diameter of 10 feet. So we got 10 feet all the way across. Water has a density of, and here's our conversion right there. We've got 62.4 pounds is equal to 1 foot cubed, and we want to find the weight in the nearest pound. So we start with our volume. Volume is 4/3 pi r cubed. Notice this is a diameter. We need the r, so that's going to be 5. V equals 4/3 pi 5 cubed. So we type that right into our calculator And when we type that into our calculator, we should get something like 523.599, which would be great if that were the answer. That is, of course, not the answer, partly because that is not one of the multiple choices, and also because that is in feet cubed. And we do not want feet cubed. We want it in pounds. So we need the 62.4 pounds. And 1 foot cubed goes on the bottom. And so when we do that in the calculator, we get 32672.6. 32,000 is right there. Now, we're going to take a look at the difference between 3 and 4. A hemispherical water tank has an inside diameter of 10 feet. A hemispherical tank is filled with water and has a diameter of 10 feet. Okay, so far it's the same thing. Water weighs this much per cubic foot versus if water has a density of this much per cubic foot. Okay, so that's the same. What is the total weight to the nearest pound? Or what is the total weight of the water in a full tank to the nearest pound? Guess what? They're the exact same question. Yes, indeed, the Regents very much likes this question, this hemispherical water tank. Why? Who knows? How many hemispherical water tanks do you normally see? Not many, but apparently quite a few on the Regents. So, since we don't care about the Regents, and since they've asked us the same question twice, we just skip right to the answer. So that's how we start doing this whole adding in the density. We start with the volume, and then we end up with a conversion factor. Sometimes we have a conversion factor in the beginning, and then we do the volume, and then we've got a density conversion at the end. Those are really tricky. We're going to take a look at those, but I'm not going to be too harsh on those. Okay. Number 5, density of an American white oak tree is this many kilograms per meter. Okay, so this many kilograms per cubic meter. So 752 kilograms equals 1 meter cubed. Okay, if a trunk of an American white oak tree has a circumference and a height. Okay, so that means that we are probably looking at a cylinder. It does sort of look like a tree right there. We've got a circumference of 4.5. That is the circumference. And a height of 8 meters. Okay, first thing we need to do is find the volume. So volume equals pi r squared h. Well, h is 8, but we do not have r. We need to go back and do what we did way over, for which question was it? It was last time. Last time when we were talking about the candle, if you remember this question right here, we were talking about the candle, we had the circumference, we had to work backwards to find the radius. We're going to have to do that again. Frequently we have the circumference and we need to work backwards to get the radius. So we're going to do circumference is equal to 2 pi r. So 4.5 equals 2 pi r. And we are going to figure out what r is, either by doing menu 31 or by dividing by 2 and then dividing again by pi. Either one would work. So we take that and we divide and we type it into the calculator and you should get 0.7162, and that is our beautiful radius. Plug that radius in, 7162 squared, pi in front. Let's get our volume. So now we need to get our volume and type it into the calculator. You can either type in menu 31 again or just type it in. I just type it in personally. And you'd get 12.8916, which is an option and is the wrong option. Be careful. We still haven't used our conversion. So this would be in meters cubed because the circumference and the height is in meters. So we need to take this 12.8916 and we need to multiply it by, this is meters cubed, 1 meter cubed, and 752 kilograms. And we want to figure out approximately the number of kilograms. Now, they could ask us to then convert it to pounds. That's a possibility too, once we have it in kilograms. They could ask us to do a lot of things with it. When you're doing this in real life, you have a goal, and so it's not as hard. In this case, we get this going on, which is answer number 2. All right, next one. Barrel of fuel. Barrel of fuel, going to be that beautiful cylinder again. So we got a nice cylinder. Inside measurements of the barrel gives us a diameter of 22.5 and a height of 33.5. And here is our conversion. 231 inches cubed equals 1 gallon. And we want to figure out how many gallons are in there. So we start with our volume. Volume equals pi r squared h. So pi 22.5 divided by 2 to get our radius would be 11.25 squared. And then h is 33.5. So we take that radius and we square it and we multiply it by 33.5 and by pi, and we should get a very large answer, which makes sense because it's a very big barrel, and we are not done. Unfortunately, we have to take this rather large answer, and this is in inches cubed. So then we do 231 inches cubed over 1 gallon. Notice in this case, we're not just multiplying by the 231. In this case, we're actually dividing by it. So your answer should be 57.66, nearest tenth, 57.7 gallons is what we end up with. Just be very careful with those conversions because for all of the other conversions, we've just been multiplying. But for this one, you don't multiply, you divide. You have to be very careful with the conversion and what goes on top versus what goes on bottom. Inches cubed is what we have, so inches cubed needs to go on bottom. Okay, next one. A wooden cube has an edge length of 6 centimeters. And it has a mass of this many centimeters, of this many grams. And we need to find the density of the cube. Okay. So first thing that we do, we draw the cube. Such a beautiful cube. And it's 6 centimeters, and it's an actual cube. So volume is equal to 6 times 6 times 6. My favorite number. So 6 cubed, or 216. Okay, so we've got 216, and that is in centimeters cubed. if we look right here, it says in order to get density, we need to do grams divided by centimeters cubed. Okay, so we got the grams. The grams is 137.8 grams. And we just got centimeters cubed, so 216 centimeters cubed. So we take the 137.8 and we divide by the 216, and we should get a density of, this is equal to density, 0.63796. Okay, 638 means we're working with ash wood. It's good to know. It's very exciting. Sometimes I wonder where the Regents comes up with these questions. Not that I'd want to know. You know, sometimes I wonder who came up with these. Trust me, when we do Papa Izzo's DIY projects, it's gonna actually make some sense. It's gonna be stuff that we actually would do. Okay. Snow cone consists of a paper cone completely filled with shaved ice, topped with a hemisphere of shaved ice, as shown in the diagram below. Inside the diameter of both the cone and the hemisphere is 8.3 centimeters. The height of the cone is 10.2 centimeters. Desired density is this many grams per centimeters cubed. Cost per kilogram of ice is this many dollars. State and cost of the ice needed to make 50 snow cones. Yeah, that sounds terrible. Okay. So the first thing that we need to do is we need to find the cone. So the cone is volume 1/3 pi r squared h. So 1/3 pi r is 8.3 divided by 2 again. So that would be 4.15 squared times h, which is 10.2. So if we're doing the cone part, that's that part. And so we do that and type that into our calculator. And we should get 183.961 when we type that into our calculator. Next part, we're going to do this up here in pink. That would be our hemisphere. Our hemisphere is 4/3 pi r cubed, and I want half of that, because half of that hemisphere is actually going to be what, or half of that full sphere gets me the hemisphere. You could just go through and do the full sphere and then cut it in half. Doesn't really matter, it's up to you. So we're going to take that 415 and we're going to cube it, and we're going to multiply that times pi, and we're going to multiply that times 4/3. So if you wanted the full sphere, that would be 299. When we get the hemisphere, that's going to be 149.693. So we take the purple and we take the pink, and we have to add those suckers together to make the whole thing. So the whole thing right now between those guys is going to be 33.654. Okay, and that's going to be in centimeters cubed. So we do 33.654 centimeters cubed, and we've got this conversion right there. So that's 0.697 grams over 1 centimeter cubed. Awesome. And the cost per kilogram of ice is this many dollars. So I would love to go right here to the cost. Unfortunately, I can't. I've got grams and it's got kilograms in there. Yeah, so we need to say that 1,000 grams is equal to 1 kilogram. How do we get that? By King Henry doesn't usually drink chocolate milk. Here is grams. So if we have 1 gram, if we have 1 kilogram right there, we want to convert to grams, we have to go 3 decimal places over, and that's going to get it into grams. So now I've got kilograms, so 1 kilogram is equal to $3.83. All right, and when we type all of those in, we get a grand total of 0.8907 money dollars. So it costs about 89 cents to make one of these snow cones. But it doesn't want one of these snow cones. It wants 50 of these snow cones. So now we need to multiply it by 50. So we multiply it by 50 and we should get $44.53. And that is the cost of the ice needed to make the 50 snow cones. That one was tricky. That one was very annoying. And that one's going to be our introduction to the scary problems. Yeah, we're going to get to scary problems, squirrel. If you notice, the last 3 questions on the homework are terrifying, aren't they? Yeah, they are. They're very scary. These are the 6 pointers on the Regents. These 3 are very, very difficult problems. I'm going to post hints about them, but I want you to try to do them by yourself. See what you can do with them. I want you to try and figure out what's happening, try and figure out how far you can get. We've got one over here with some trigonometry. We've got this guy over here, which is just terrifying, but I've got some steps there to help you. I want you to try and do the last 3 by yourself. See how far you can get, because these are the types of problems that show up in real life when you're doing geometry. They're extremely complex, there's a lot of different steps involved, and they do get scary. Yeah, they will get scary, squirrel. I know, but it's okay, they can handle it. Your mission is to finish up this packet all the way to page 38. So you will have pages 27 through 38, and I want you to get me those by April 27th. Now, how do you get me those? Who remembers? Squirrel, do you remember how I told them to get it to me? No? Well, you have to do a video. So using your phone or your device, whatever device you might be using, do a video. So show me you, show me your pet, show me your siblings. Just at some point in your video, I want you to take your packet out and show me which of the lessons you've done in your packet and which ones you like, which ones you don't like, which ones you can get, which ones you can't get. And then on the 28th, we'll be starting a brand new unit, DIY Papa Izzo. All right, thank you very much, and have a wonderful day.